हेलो स्टूडेंट्स। नेक्स्ट जो हमारा टॉपिक है वो सब स्पेसेस का है। सब स्पेस ऑफ ए वेक्टर स्पेस, और इसकी डेफिनेशन है ए नॉन एम्प्टी सबसेट W ऑफ ए वेक्टर स्पेस V और F। वी एफ आप अच्छी तरह समझते हैं इसकी नोटेशन को। V वेक्टर स्पेस है और ओवर ए फील्ड F। Then a non-empty subset W of a vector space Vf is said to form a subspace of V if W is also a vector space over F। Means कि W भी वेक्टर स्पेस की वो सारी प्रॉपर्टीज सेटिस्फाई करता है जो कि एडिशन के रिस्पेक्ट में और स्केलर मल्टीप्लिकेशन में जैसे V ने सेटिस्फाई की थी। और इन view of definition, a non-empty subset W of a vector space Vf is said to be a vector to form a subspace of V if W is also a vector space over F with the same composition of addition and scalar multiplication for V। एग्जाम्पल के तौर पे यहाँ पे हम देखते हैं, लेट अस सपोज दैट W1, इसके एलिमेंट लिए हमने A 0 0 and this A belongs to R set of reals। This is a three tuples point here A 0 0 and it is a subspace of R3। W2 contains element A B C। A, B, C all belongs to R, also a subspace of R3। Here W1 is subspace of W2 also, as well as R3। Therefore, these are the examples of subspace। Another example is, or you can say, trivial subspaces। Zero space, zero, and V itself are trivial subspaces of V। Beside these two, all other subspaces are called non-trivial subspaces। Here are some theorems based on this subspaces. Let's discuss them. The statement of the theorem is, a necessary and sufficient condition for a non-empty subset W of a vector space Vf to be a subspace of V is that W is closed under addition and scalar multiplication। Let us prove this necessary condition। First of all, let us prove the necessary condition। If W is a subspace of V, then by definition we know that all properties of subspace also holds in W, means W is a vector space over F, and it means for U and V belongs to W, U plus V, यानी कि their sum U plus V also belongs to W, and for U belongs to W and A belongs to F, AU also belongs to W। Both are satisfied here because by definition condition is necessary satisfied। Condition is sufficient। For this, let W is W is closed under addition and scalar multiplication. We have to show that W is a subspace. Let us suppose that W is closed under addition and scalar multiplication. Then for U and V belongs to W, their sum also belongs to U and V. Also, their sum also belongs to W. And second property, for U belongs to W and A belongs to F, AU also belongs to W. Since one is multiplicative identity या identity with respect to multiplication बोल सकते हैं, then -1 also belongs to F. It means -1 into U also belongs to W, or -U also belongs to W. It means for every U there is a -U belongs to W. It means additive inverse exists. Additive inverse exists in W. This means U plus -U belongs to W, or 0 belongs to W. Additive identity, 0 belongs to W here. 0 element also belongs to V, and also it means 0 belongs to W. Also, for U and V belongs to W, we have their sum U plus V is equal to V plus U, because UV belongs to W, and this for UV belongs to W, this UV also belongs to V, but V is a vector space, and vector space के अंदर commutative property hold करती है. It means U plus V is equal to V plus W, because V with respect to addition and multiplication is an abelian. Abelian group यहाँ पे है ये. तो U plus V is equal to V plus U. Similarly, as the property of addition and commutativity satisfied, similarly associativity and other properties of vector space also holds in W, as in V. Hence, W with respect to addition is abelian group, and this means W is a subspace. In this way, we can say that this is a subspace. Both the properties satisfied है. Necessary condition में हमने क्या किया, उसको subspace consider किया और उसको closed show किया, because property satisfy in vector space. Condition sufficient में हमने properties ली, that is this is closed under addition and scalar multiplication, और उसके बाद जो vector space की property थी वो हमने satisfy कर दी, क्योंकि उसमें additive inverse, additive identity दोनों प्रूव किए, साथ में कम्यूटेटिव लॉ प्रूव किया, और सिमिलरली आप एसोसिएटिविटी और दूसरी जो प्रॉपर्टी है वेक्टर स्पेस की, ऑल वी कैन सेटिस्फाई, एंड देयरफॉर दिस W इज ए सबस्पेस ऑफ V. सबस्पेसेस की जो नेक्स्ट थ्योरम है वो है ए नॉन एम्प्टी सबसेट W ऑफ ए वेक्टर स्पेस VF इज ए सबस्पेस ऑफ V if and only if AU plus V belongs to W, for each A belongs to F and UV belongs to W. Means definition में सीधा सा बताया हुआ है कि necessary and sufficient condition for W will be a subspace of vector space V is that AU plus V belongs to W. मीन्स इसमें एडिटिव प्रॉपर्टी एडिशन भी आई, मल्टीप्लिकेशन AU भी आया, बहुत प्रॉपर्टीज इसके अंदर आई, और वो एलिमेंट अगर सच टाइप ऑफ एलिमेंट्स अगर W में लाई करेगा देन वी कैन से दैट W इज ए सबस्पेस ऑफ W. Similarly, we can prove this as in above theorem, condition is necessary. Necessary condition. Let us suppose that let W be a subspace. W be a subspace of V. W then W is subspace of V, and W is closed under addition. पिछली थ्योरम में हमने यही पढ़ा था, एडिशन एंड स्केलर मल्टीप्लिकेशन. This means for U and V belongs to W and A belongs to F, AU belongs to W as well as U plus V belongs to W. Also, if AU belongs to W and V belongs to W, this means AU plus V also belongs to W, and property satisfied, necessary condition satisfied. To prove the sufficient condition, yeah, condition is sufficient. For this, let W is a non-empty subset of V. V का हमने non-empty subset ले लिया. Such that property satisfied, such that AU plus V belongs to W. For A belongs to F and U and V belongs to W. Then for 1 belongs to F, minus 1 also belongs to F because F is a field. Now for this, let us suppose that we have another element W, and let us take V is equal to U is equal to W, for W belongs to W and A is equal to minus 1. Then putting all the values, putting all above values, we get minus 1 into W plus W is equal to minus 1 into W, which is equal to minus W. Minus W, यहाँ पे प्लस में एक W भी था. W is equal to minus W plus W, which is equal to 0. It means 0 belongs to W. 0 element, additive identity W के अंदर एग्जिस्ट करती है. सेकेंड प्रॉपर्टी यहाँ पे हमने फर्स्ट प्रूव किया था. सेकेंड प्रॉपर्टी के लिए फॉर A belongs to F, A belongs to F and minus 1 also belongs to F, and W is closed, the subspace वाला W है, W is closed under this is closed under. उसके लिए इससे पहले आप ये प्रूव कर लेते हैं A belongs to F and माइनस वाले से पहले अब एक प्रॉपर्टी और यहाँ प्रूव कर लेते हैं. फॉर A belongs to F and U belongs to W, U belongs to W, taking V as 0, then AU plus 0 also belongs to W. It means W is closed under under scalar multiplication. स्केलर मल्टीप्लिकेशन के अंदर क्लोज्ड शो करने के लिए हमने क्या किया, एक एलिमेंट f का, दूसरा w का, और v को 0 ले लिया, बिकॉज दिस प्रॉपर्टी सेटिस्फाइड इन w, देयरफॉर au प्लस 0, v को 0 लिया है, ऑल्सो बिलोंग्स टू w, एंड इट मीन्स au टाइप का एलिमेंट भी उसके अंदर है, इट मीन्स स्केलर मल्टीप्लिकेशन इसके अंदर सेटिस्फाई होती है। थर्ड जो प्रॉपर्टी जो हम ऊपर कर रहे थे वो वाली है ये, फॉर u बिलोंग्स टू w and -1 belongs to f and w is closed under scalar multiplication. अभी प्रूव किया है, multiplication then -1 into u is equal to -1 into u is equal to minus u belongs to w. Therefore, for every u, its additive inverse also lies in w. Fourth property, and since 1 belongs to f, and let us take in au plus v, take this a equal to 1. तो गिवन कंडीशन में पुट करेंगे तो क्या बन जाएगा, 1 into u plus v is equal to u plus v belongs to w, and this means for uv, u plus v belongs to w. It means w is closed under addition. Therefore, property of associativity can also be satisfied, and therefore the W is a subspace. All other properties can be satisfied. Therefore, W is a subspace of vector space V or field F. Okay.